Myself, Professor Doshi from ADSUL'S Technical Campus, JAS, Ahmedabad. Last lecture, we have discussed about the performance of transformer. To calculate the performance of transformer, we have to use two types of method. First is direct loading method, and second is indirect loading method. So last lecture we discussed about indirect type of loading methods to calculate the performance of transformer. That lecture we have discussed about a short circuit test and open circuit test. We briefly discuss about the open circuit test. This open circuit test and short circuit test we perform on a transformer to find out the performance, that is regulation and efficiency of the transformer by without applying actual load. So that means by using the open circuit test and short circuit test, we calculate the circuit parameters. These parameters are further useful to find out the efficiency and regulation of the transformer. In case of open circuit test, we calculate the parameters which further useful to calculate the efficiency and regulation. So in this lecture we have to discuss about the parameters of short circuit test and what is the exact procedure to find out the short circuit test parameters by using the short circuit test. So let's start our session. Short circuit test. In case of short circuit test, one winding, usually low voltage winding, is short circuited by using a thin copper wire or link. Some cases we short circuited the low voltage winding by using the ammeter also to find out the load current. But usually we use a link to short circuit the low voltage side. So we draw here a circuit diagram which clearly explain you how to perform the short circuit test. We have to connect here one voltmeter. After that we draw here wattmeter. We mark this wattmeter as WSC. This WSC measures the full load copper loss or the copper loss of whole transformer. Okay. After that, we have to connect this apparatus with the high voltage side of the transformer. High voltage side of the primary transformer we mark as a HV side. After that we have to connect the low voltage of the side, low voltage side of the transformer, and we shorted the low voltage side of the transformer. This is the LV side of transformer. So this is the circuit diagram of short circuit test. What we connect here, we have to connect LV supply, low voltage supply, to the primary of the transformer with 50 Hz constant frequency. Okay. After that, we connect here 1 voltmeter. After that, we have to connect here 1 ammeter. Okay, we have to connect here 1 ammeter which measures the ISC, short circuit current. Okay, this measures the WSC, and HV side of the transformer is connected with the supply, and LV side of the transformer we shorted by the link or a thin conductor. Shorted by a link or a thin conductor. Sometimes this link can be short circuited by ammeter to calculate the rated load current. Okay. Sometimes we can connect here by ammeter also, but we have to understand and note that the rating of this ammeter should be high range ammeter. Okay. Then while performing the experiment, a low voltage side is connected usually with 5 to 10% of rated voltage. Means we have to apply from this supply side 5 to 10% voltage of the rated voltage. We have to apply only 5 to 10% voltage. Okay. After that, we have to increase slide, means exactly what, if the voltage is 230 volt. Okay, then we have to apply here only 10 volt, approximately 10 volt to 20 volt voltage. We have to apply here only 10 to 23 volt only. So after applying the initial voltage from the supply side, we have to increase slightly the voltage level. Okay, we have to increase slightly the voltage level till the ammeter measures the full load rated current. Okay, if the ammeter measures full load rated current, we have to stop the electrical supply for the applying voltages. Okay, if the voltmeter measures the rated voltage, then we have to stop our supply. Okay, so applied voltage is very small. Since the applied voltage is very small, we have applied here only 5 to 10% of the rated voltage. If the rated voltage is very small, then the generated magnetic fluxes, that is phi m, the fluxes is called mutual flux between the primary and secondary. The applied voltage is very small, then the mutual fluxes produced also small. Okay, if the mutual fluxes are small, hence the core losses are very small. Got it? What happens here? Applied voltage is very small. The applied voltage is very small. Because of that, the mutual fluxes also get very small. When mutual flux induces are also very small. If the mutual fluxes are very small, then the total core losses are very small. These core losses read or observed by this wattmeter. Okay, this wattmeter measures, or this wattmeter shows the reading of total Cu losses or the copper losses. These copper losses also called as I square R losses. Okay, this loss is also called as I square losses, and this copper losses are the total copper losses, means primary as well as secondary, or these losses are losses of whole transformer. Okay, got it? Then now we have to draw the equivalent circuit to for the equivalent circuit parameters. So let's we draw here equivalent circuit which shows us equivalent circuit parameters and how to calculate these equivalent parameters. Okay. Now I will draw here the equivalent circuit referred to primary as well as secondary side of the transformer. This is R0, this is X0. Okay. Here E1 equals to E2 dash. Okay. Here E1 equals to E2 dash. This is R1, this is X1, and this is R1 dash, this is X1 dash. Okay. R2 dash, X2 dash, and this side voltage of V1 equals to 0. Okay. Next, we have to draw here impedance. We have to show here impedance. Okay. This is R01 dash. This is X01, and the combination of R and X is we call impedance. Okay. We call here impedance. Here we have to show the current, which is I1 equals to I2 dash, and there we have to show the current X1 equals to I1 equals to I2 dash. I1 equals to I2 dash. Okay, and V2 dash equals to 0 because this link is short circuited. This link is short circuited. Okay, by using this equivalent circuit we can write here the equivalent circuit parameters. First equivalent circuit parameters we can draw Z01 equals to 1. Then Z01 equals to we can draw by using these circuit parameters VSC upon ISC. Right, we can draw here VSC upon ISC. Okay, by using the Z01. After that, we know that the W means W0 or WSC is nothing but the total copper loss. Therefore, we can write here W equals to I square R. Okay, I square R. This is R1, R0, 1. Okay, you can draw here W equals to I1 square R0. Okay, by using this we can also write here R01. What we can write here? R01 equals to W upon I1. finally we can write x01 equals to, we can find right here x01 equals to under root of z01 z01 square minus r01 square. Okay, finally we can write here x01 equals to z01 square minus r01 square. Okay, by using these parameters we can find out easily efficiency and regulation, that is performance of transformer. Okay, both lecture we understand open circuit test and short circuit test. In the open circuit test, we find out the open circuit test parameters. In case of short circuit test, we can find out the short circuit test parameters, and by combining both the parameters, we can easily find out the efficiency and regulation of the single phase transformer. Okay, while performing this experiment, we have to always note that the supply of the primary side should be always 10 to 5 to 10% of the rated voltage, and we have to short the LV side of the transformer. We have to give the supply to the primary side of the transformer, and we have to short the LV side of the transformer. Sometime we can short the LV side of the transformer by using the ammeter also to calculate the rated current. Okay, I hope